For this question, we're supposed to see which of the following is a possible path, okay, of the alpha particle. So first up, right, let's recognize that the reason why the alpha particle is deflected is because, right, it has a charge of plus 2e, gold nucleus is plus 79e. So there's a electric force, and this electric force is repulsive. Gold nucleus is very massive, it's going to stay put, it's not going to move. It's the alpha particle that will fly away, okay? Next up, right, how do you know which shape? Okay, it's always, right, the shape of the resultant path is always in relation to the initial path, right, and the location of the alpha particle. So let's look at the 4 diagrams here, right? You see, the first path, right, is like just above, so you're going to get really close, almost like a head-on kind of collision. So therefore, right, the scattering will be very sharp, okay? You'll cause it to bounce off with a big angle. For that matter, right, you can imagine if the alpha particle, right, were to really come head on towards the gold nucleus, right, so this guy will actually make a U-turn back. Okay, yeah, and that would be the extreme lah, if it's exactly head on. So therefore, when you increase this gap here, then the angle, right, will become smaller and smaller. So that's how you gauge. And if you have to draw in exam, right, from scratch by yourself, right, in a structured question, so you got to make sure, right, that you draw this curvature here like it is the opposite of a circular motion like that. Okay, what do I mean? You see the repulsion, right, let's say of the alpha particle on the alpha particle on this at this point will be in this way. So it is like a inverse of a circular motion. Or for circular motion, the centripetal force pulls towards the center, right, and the path is about the center of the circle. Here is, right, it swerves away about the gold nucleus. So you must draw it in such a way, right, that it makes geometric sense. Okay, yeah, and yep, I've also appended another diagram here. It's just for your reference, to see that the gold nucleus, the alpha scattering experiment, right, the large scattering compared to the small scattering, right, you see, small angle scattering is most of them is like a 10 to the power of 6 to 7. It's like a million to 10 million, whereas, right, the large angle scattering is like 10 to the power of 1, 10 to the power of 2. Okay, so it is around, right, 1 in 10 to the power of 5 to 10 to the power of 6. Okay, that actually undergo large scattering. So this ratio, right, actually shows the ratio of the size of the nucleus in relation to the size of the atom. Okay, nucleus is around 10 to the power of minus 15 meter, and whereas, right, the atom is around 10 to the power of minus 10 meter. So this chart, right, gives rise to a rough sense of the relative size